Today we're doing something hopefully fairly familiar to you. Position, velocity and acceleration. So you guys from topic 2 are used to deriving to get velocity from the position and deriving to get acceleration from the velocity. Yeah? So now we're going back the other way. So if we have the acceleration, we integrate to get the velocity. If we have the velocity, you integrate to get the position or the displacement. Okay? Displacement is a distance from the origin. Okay? Or it is a distance with a direction. Velocity is a speed with a direction. You can see from the notation on the screen, we have position in terms of time, velocity in terms of time, acceleration in terms of time. So first example, just refresh your memory of derivatives. Find the velocity of a ball if its position is given by that. So we do the derivative in terms of, so velocity is derivative of the position in terms of time. So derivatives, what's the general rule? Just an equation with a power. What do? You bring the power out the front and minus 1 from the power. So you're just left with 1 as the power. Pretty straightforward. Okay, so that's from position to velocity, deriving. So now we're going to do the new stuff. Find the velocity of the car if its acceleration is given by a equals negative t plus 5. And it starts at a speed of 10 meters per second. So it wants us to find velocity. If we have acceleration, what's the velocity? Perfect. Someone's actually listening to what I'm saying and not talking about what they had for lunch. All right, so this time, instead of minusing the power, bringing it out the front, what do? Add 1 to the power, so it becomes 2, divide by the new power. Add 1 to the power, currently it's t to the power of 0, so it becomes t to the power of 1, divide by 1, and then we need the plus c, remember. So now we have the velocity in terms of time using integration. Yep, so the next step is using this information. It starts at a speed of 10 meters per second. So how can we use that information, do you think? Yep, so we can use that to find the c. So at the start, what does that mean? T is 0. So assuming at the start means t is 0, you sub in 0, so you got 0 plus 5 times 0 is 0 plus c, and this all equals what? 10. So we found the value for c. There you go. The car velocity. Woo! So exciting! There it is. So that's kind of the basics. You know, then you can put in like, what's the velocity after 20 seconds or stuff like that. Okay? There's lots of different applications. This is just the bare basics. Integrating to get from velocity, from acceleration to velocity or from velocity to position. Yeah? A really common application is gravity. So it says the acceleration is what? Negative 9.8 in the downward direction. And it's saying find the velocity from that. Okay? That's a really common application. Or find the position from that